Okay, everybody, this is 4.2. This is a triangle congruency, and there's a couple of, or four theorems that we're going to learn right away about how to prove that triangles are congruent, and then we got two more kind of down the road. Then there's going to be one that's kind of a for special circumstances that we use later on. Okay, so what this big thing here is proving that triangles are congruent with some information that we got, or that we can prove. This is a pretty proof heavy section along with the couple that follow. So really making sure you're taking notes. Remember, proofs are not hard. You just gotta tell me what you see and be able to understand where you're trying to get to at the end. And actually the ends here are pretty, it's nice that we know these things because we're trying to work towards something like SSS and SAS. Those are acronyms that kind of help us to remember these different triangle congruencies, okay? So, and I kind of did SSS right at the very end of section 1, so maybe you remember that from a previous lesson, okay? You guys go ahead and draw the two triangles that are congruent. We're giving you all kinds of information here, and then we want to be able to name the figures that are congruent, and then name the congruent size and angle. So you're really, you're making a congruency statement, which we did last section. So this shouldn't be kind of news to you, okay? Now, just kind of help you here. These two figures are not X's. They're arcs for the angles, and they put a line through it just to kind of do it so they didn't have to do like 3 arcs, because that gets kind of messy. So it's just showing those two angles are congruent with that different kind of mark, okay? So I'm gonna let you guys pause it. I'll let you write the congruency statement. Remember, these are triangles, so I'm going to have 3 sides are equal to the other 3 sides, 3 angles are equal to the other 3 angles, and then I need to say, hey, this triangle is now congruent to that triangle. So you're going to need 7 pieces to be able to do that. So if you want to hit pause, take a few minutes to write that out, and then I'm going to put up the solution, okay? Okay, so there's your congruency statement. I started with the angles, I started with A, and I just went around. You could have started anywhere else, as long as you got corresponding pieces being congruent to each other. And then over to the sides, you can start wherever you want, but just got to make sure that the congruency is to corresponding parts, and the order of how you write at least the first group. Then you got to match the second group in order, okay? And once again, I'm going to say this a bunch of times, I'm not going to kill you on a test if they're not in exact order, but I've got to at least have corresponding pieces being congruent, okay? And then my last step is just saying the 2 triangles are congruent. Once again, just being very careful that I have the same order, okay? All right, if you can come down here to 4.1, you don't need to write 4.1. But we're going to go ahead and write the rest of it, and I'm always going to refer to this particular theorem just using the abbreviations here, SSS. And since we're here, let's go ahead and do this next one, and I'm going to always use acronym or abbreviations SAS. Okay, so if you could just take a moment, write those two down, give yourself a little bit of room. I'm going to draw some pictures to help illustrate it and help you with your notes. So if you want to hit pause, then I'll put the drawings up, and then you can get the drawings once you're done with the two definitions or postulates, okay? Okay, so we kind of done side, side, side. If I have three sides of one triangle congruent to the corresponding sides of a second triangle, now I can say all three, or the two triangles, I'm sorry, the two triangles are now congruent, and I would say they're congruent by S, 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 side, side, side. Okay, so we've kind of already done that and talked about that one pretty good. So the first one is really a big one, is I can prove that a triangle is congruent by side angle side. And that's now saying if I have two sides of a triangle are congruent to corresponding sides of a second triangle, and the included angle is also congruent, now I can say the whole triangle is going to be congruent. All the angles, all the other sides I don't know anything about, I can say they're now equal. Okay, so the included sides kind of what kind of is something we got to understand. The included side is, or the included angle, I'm sorry, the included angle is the angle that's being made by the two sides that are equal to the other two sides in the other triangle that are corresponding, and that angle is also congruent to the previous triangle. Okay, so, and I hope you understand that if the two sides are equal and they're creating an angle that's also equal, then this side right here has to be equal to that side. Okay, there's no other way to redraw that, and therefore now I've got a kind of a side, side, side thing that just lets me go ahead and say that this angle is going to be equal to that angle, and so on. Okay, I can say this third angle is going to be equal now because now I can use the third angles theorem. So it's kind of really all connected. All right, now I just want to make sure you understand too, it's not just the way I drew this first one. It could be any two sides are equal, but it's creating an angle that's equal to the same angle in the other triangle. Okay, so let's go ahead and practice this a little bit. If you guys could write out what's given to you and what you need to prove, and then draw the picture, and then you could go ahead and draw your two-column proof. You could hit pause and get this finished, then come on back, and then we'll do the solution to this. Okay. Okay, so they've given me some things that are congruent, or they've just given me some information. They went and marked it. I'm just going to make sure we understand that I got these sides that are equal. Okay, and I hope you see this is really technically this is a kite figure. It's something we'll learn later on in the year, but this kite's really been cut into two triangles. I hope you can see that that line BD is actually cutting that kite into two different triangles. All right. So now what I need you guys to, there's a big rule here that we use in geometry that's like your buddy. Like last chapter we learned about transitive property when we were working with transversals, okay? And transitive property showed up everywhere. And we used it in our proof. It was like always something we could rely on to be there. Whenever you see a figure like this kite being cut into two different triangles, I hope that this is going to make things a lot easier. This line right here, BD, is really part of both triangles. And so when you guys get up in the morning and you look in the mirror, you know, you're doing your teeth, doing your hair, whatever, you're looking at a reflection of yourself, okay? And I keep Home Depot in business because my mirrors crack in the morning when they see me. So I'm always buying new mirrors for the bathroom. Anyways, the reflexive property means that something is equal to itself. So in this case, the line BD is equal to the line BD. Okay? And that's always something I can use, especially when some figure can be cut. You know, we're going to be cutting triangles up with a diagonal. Did I get two triangles? Yes, I did. Is this diagonal part of both triangles? Yes, it is. So that's reflexive again. So this is going to be another one of those buddy things that it's always going to be in there for you to use. Just got to make sure you use it, all right? So we're going to say that BD is congruent to BD by the reflexive property. And show it on your picture, okay? This is just critical to that you illustrate yourself so you can see what's going on. I have two distinct triangles, and with what I just did, I've got two distinct triangles that all three sides are now equal to each other. Okay, so can I prove what they want me to do is prove, are the two triangles congruent? Yes, they are. So triangle BCD is congruent to triangle BFD, and that's by side, side, side. All three sides are equal, so I can use that theorem. Okay, so what's going to happen is we kind of go through this chapter and stuff. We're working to get to this typically 95% of the time, these different theorems we're going to use. This is number 1 of 4. I'm working to get to this one at the very end. Okay, so finding sides, or and we're going to see in a second using angles to help us with theorems. We're working to these things, so you got to know them. It's not that hard to understand them or study for them. Okay, we're going here. If you guys could write down what's given and what we have to prove here, and if you could go ahead and draw the figure. I'm going to move this figure a little bit out of the way so I can. Move this figure a little bit so I got some room. Good enough for what we're doing. Okay. And then if you go ahead and write in a 2-column proof. Okay. And then this is really getting into a proof that there's a lot of stuff we have to be aware of and think. Okay. It's not that hard to think here too. So taking the given. Hold on, getting messy here. Okay, it's given, and show it now. Now they're kind of taking away the training wheels and making us kind of use our illustration. All right. First off, remember this, what this symbol up here means. It means lines are perpendicular, which says that I've got a 90-degree angle. So DR is going to be congruent to AG, or not congruent, I'm sorry, perpendicular. So that's going to give me an angle of 90 degrees. Now, I got to make sure I say this because I assume stuff sometimes. Remember this AG at the bottom here, the base is a line. The line's 180. So if part of that line's 90, then the other part's going to be 90. So I'm assuming that we all remember and know that, but it's just stuff that's going to keep coming up. And we got to be on top of our rules and be aware of things because they're going to help us. Okay. Now you're looking at this, and I forgot one more thing. RA is congruent to RG. Okay. Now I'm trying to prove that the two triangles are congruent. So I'm trying to prove this one on the left is congruent to the one on the right. Okay. So I hope you see it. I've got one big triangle, but now that DR has cut it into two different smaller triangles. Okay. I'm trying to prove the smaller ones are equal. So what else do you know here in this picture from what we were given and what we're trying to prove? And I'm going to give you a little cheat sheet here. I'm trying to prove it again. I said this at the last end of the last proof. I'm trying to get to the last step of getting one of those two things to say that triangles are congruent. Okay. So if you go back to some of the other things I talked about, is DR cutting the big triangle into two other triangles? And it is. And is DR part of both of those two smaller triangles? And it is. So remember, that's reflexive. Okay. So the reflexive property does one bigger figure gets cut into two smaller, in this case, triangles. And we're always working towards triangles. All right. I got that, and show it now, okay? Because I think sometimes illustrations lead us to understanding stuff. So let me just, can I ask you guys, can I prove it by SSS? Are all three sides of both triangles congruent to each other? Well, I've got two, but not the third, okay? But do I have an angle that's congruent to both triangles? And is the angle being created that are equal? Are they being created by the sides that are equal? And yes, they are. This side and this side of the triangle on the left create that right angle. This side of the right triangle are creating this right angle. So I can now I've got a side angle side situation. Okay, the included angles equal, created by the two sides that are also congruent. So I can say triangle DRA is now congruent to triangle DRG. Okay, and then what is the reason allows me to do that? So last step, I'm getting to one of these two that we've learned about so far. Okay, all right. Let's go down here to this next one. If you guys can go ahead and write down what's given to you and what you have to prove. If you go ahead and draw your, this is a rhombus. If you could draw the rhombus, and let's see if I can move it. Oh, this one's easier. Thank you. Give myself a little bit more room, and then go ahead and draw in your two-column proof. And we'll get going on this one too. So if you want to hit pause and then come back, I'm going to start the solution right now. Okay. So once again, they're making us, take what's given to us and let's go show where that's at. They're saying that AD and CB are congruent, and then they're also telling me at the same time that they're parallel. So I'm showing that that's given. All right. So now from here, we're going to have to say, what do I know? What do I see? Be able to go there. So I hope that we're getting to this point here. You got a rhombus, but the rhombus has a diagonal through it. Is the rhombus now really two different triangles? Yes, it is. So therefore this diagonal is part of both triangles. So therefore it's reflexive. And the reflexive property. So we've done 3 proofs so far in this section, and the reflexive property has been in each one. And little cheat sheet, remember, I'm trying to work towards this. One of those is my last step. I just got to prove one of them. Okay. So what else? And let's mark it 2. What else do we see in here and know from this figure? Okay, and right now I think a lot of us are kind of going, I'm not really sure there's anything else there I can say. I know I said it's a rhombus, and a rhombus, all 4 sides are the same, but maybe it's a parallelogram when it's not. And there's no way for me to prove it, so you can't just make assumptions either. Kids sometimes want to just start making stuff up when they're not really sure. Okay, so let me give you a little clue here. Parallel lines take us back to last chapter when we were dealing with transversals. So whenever, a key here is whenever I see parallel lines, I'm going back to chapter 3, transversals. I've got a transversal, parallel lines, with the transversal line being this diagonal, okay? And if you remember what transversals do, there's a bunch of triangle or angle measures and angle congruencies and supplementaries and stuff. You got to go there. And I'm going to tell you right now, once you got something like this, you're always thinking of alternate interior angles. This is going to be something that's going to show up a whole bunch of times. Sometimes same side interior angles too, or another one that will show up. But in this kind of picture, the inside here is always kind of the one that's going to give us a little bit of help. All right. So a couple things we could do here. You got to be a little bit careful with this one too, and what you're looking at. I've got 2 sides that are equal here, and I've got 2 sides that are equal there from different triangles. So maybe there's a way I could prove a 3rd side's equal, but if I'm using transversal, that only dealt with angles. So if I look right here with a transversal, these 2 angles would be equal because they're alternate interior angles, and those 2 angles are being created by the 2 sides that are equal from each triangle. Okay, so I could say now that I have to use 3 letters here. Angle DAC is congruent to angle BCA. And that's by alternate interior angles. So stuff you learned last chapter is coming back, and we're needing to use it again in another chapter. So math is notorious for always building on top of stuff that we learned before, and geometry is like the most important until you get like the calculus. Okay, so we got to make sure you're studying, putting some time in. Now, some of you guys might have said, well, okay, alternate interior angles, these angles over here are alternate interior angles. Okay, and you're correct. You are absolutely correct, because there's 2 pairs of alternate interior angles in a transversal. But these angles that I did in green, are they being created by sides that are congruent? And they're not. Okay, this diagonal is congruent to itself, but I would need this side and this side to be equal, or some way to prove it, and there was no way for me to do that. Okay, so got to be careful which angles you're using, how you name it. That'd be something I'm looking for when I grade a test or a quiz, that you're using the correct ones. Okay. Now, once I've done that, do I have side angle side to prove the 2 triangles are congruent? And I do. So triangle. Let's see. They gave me ABC is congruent to triangle C. Triangle CDA, and that's going to be by side angle side. Okay. So last step, once again, was for the 2. We got 2 theorems today dealing with how to prove that triangles are congruent, and they're always in the last step. Okay, so that was it for 4.2. Please, once again, go over your notes, do a good job with your classwork that goes with it. If you have some issues, please make sure you get a hold of me, but you got to put some time in it.
Okay, thanks, bye.